Welcome to The Explainer. Today, we're going to tackle one of the biggest questions out there, and we're going to see how the weird physics of a spinning universe just might hold the key.
So let's just get right to it. Can we travel back in time? I mean, we've all dreamt about it, right? But what might really surprise you is that if you ask the laws of physics, the answer isn't a hard no, it's a maybe.
Okay, I know what you're thinking. That sounds like something straight out of a Hollywood movie. But this isn't science fiction. This wild idea, it comes directly from Albert Einstein's general theory of relativity, which is, our best understanding of how gravity actually works.
But hold on. Before we can even think about breaking the rules of time, we gotta understand the rules in the first place. Why does time seem to move in only one direction? What is it that locks us into this forward march?
I mean, it feels totally fundamental, doesn't it? Time is a one-way street. You can't go back. But that feeling, it's not just in our heads. There's a really powerful law of physics that backs it up.
And that law, it all comes down to one big idea: entropy. So what is it? Well, you can think of entropy as a measure of disorder or randomness, and the universe, it has this unstoppable tendency to move from a state of order towards disorder.
This isn't just a vague idea. It's a hard rule called the second law of thermodynamics. It basically says that the total amount of messiness in the universe can only go up, never down. Think about an egg. You can scramble it really easily, right? But have you ever seen a scrambled egg unscramble itself? No way. That inability to go backward, that's what we call the arrow of time.
And for a while, that seemed to be it. Case closed. Time moves forward, end of story. But then, Albert Einstein entered the picture. And he didn't just tweak our understanding of things, he completely blew it up, especially when it came to space, and more importantly, time. So here's the game changer. Before Einstein, people thought of space as this big, rigid box, a cosmic stage, and time was this universal clock that ticked the same for everyone everywhere. But Einstein said nope. He showed that they're actually woven together into this one dynamic thing called spacetime. And here's the crazy part. This space-time fabric isn't fixed. It can be bent, stretched, and even twisted by heavy things like planets and stars. Okay, so once you have a flexible, bendy spacetime, you open the door to some really weird possibilities. And one of Einstein's good friends, a genius logician named Kurt Gödel, decided to push Einstein's equations to their absolute breaking point. And what he found? Well, it even freaked Einstein out a little bit.
Gödel basically came up with a mathematical model for a whole universe. A universe that was perfectly allowed by Einstein's own math, but was unlike anything anyone had ever imagined. And it had one very strange feature.
He pictured a universe that was spinning. Now, not like a basketball on your finger, where it's spinning around a center point. No, in Gödel's universe, everything was spinning, everywhere, all at once. The very fabric of space-time was in a constant, universal rotation. He had to add in this weird kind of anti-gravity to hold it all together, but mathematically, it worked. It was a totally valid, if completely bonkers solution.
Okay, so this is where things get wild. Let's really dig in here. How on earth does a spinning universe let you travel in time? Well, it all has to do with something physicists call a light cone.
All right, just imagine where you are right this second, in space and time. Your light cone is basically a map of everywhere you can possibly go in the future. The edges of the cone are set by the speed of light, the ultimate speed limit. So normally, this cone points straight up into the future, keeping you on that one-way street we talked about.
But in Gödel's spinning universe, things change. That cosmic rotation literally drags space-time along for the ride. It's like stirring a thick cup of coffee. The coffee swirls with the spoon. This effect is called frame dragging. And what it does is it starts to tip those light cones. And if you travel far enough away from your starting point, those cones tip more and more and more,
until they tip over so far that part of your future is now pointing into your past. And when that happens, you've created a path, a loop in space-time that physicists have a great name for: a closed timelike curve, a CTC.
And that's exactly what it sounds like. A CTC is a literal loop-the-loop in space-time. It means you could get in a spaceship, fly along a certain path, and end up right back where you started, but also when you started. You would have traveled through time, back to your own past.
Yeah, I know.
It's mind-bending. But of course, as soon as you open the door to time travel, you immediately run into some huge headache-inducing problems. We're talking about the famous paradoxes.
And the classic, of course, is the grandfather paradox. You know how it goes, right? You build a time machine, you go back, and you prevent your grandfather from ever meeting your grandmother. Well, if they never meet, you're never born. But if you were never born, then who went back in time to stop them? It's a complete, unbreakable, logical nightmare.
So are we just stuck? How do physicists try to solve this? Well, there are a couple of popular get-outs. One idea is that you simply can't change the past. Anything you do was already part of history to begin with. The other idea is even wilder. Maybe by going back, you just splinter off into a whole new timeline, a parallel universe, and your original timeline is completely safe.
Okay, so let's get back to reality for a second. Could our universe actually be one of these spinning Gödel universes? The answer, pretty definitively, is no. For one thing, Gödel's universe doesn't expand, and we have tons of evidence that our universe is expanding. So his model is more of a theoretical what-if, a thought experiment, not a map of our own cosmos.
But that brings us to one last really fascinating question. Okay, so our universe isn't a perfect Gödel universe. But what if it's spinning just a little? Could even a tiny bit of cosmic rotation create these kinds of time travel loopholes? It's funny, Stephen Hawking used to tell a story that for the rest of his life, Kurt Gödel would ask every astronomer he met, "So, is the universe rotating yet?" He was always hoping for that little piece of evidence, and as far as we can tell, the answer is still no. Our universe seems to be perfectly still. But Gödel's discovery left us with this incredible, lingering idea. Maybe the laws of physics don't actually say that time travel to the past is impossible. They just say it's really, really, really hard.